Right, so here we go with CCEA, A2 Physics, Unit 2, Fields, Capacitors and Particle Physics for June of 2018. Let's get started. Question 1. The time constant of a resistor capacitor RC circuit can be determined using the circuit shown in figure 1.1. Define the term time constant. So that's just straight bookwork out of your notes. The time constant for a discharging capacitor is the time taken for the voltage across the capacitor to fall to 37% of its original value, or 1 over E of its original value. So something like that. Part 2. Describe how the circuit in figure 1.1 could be used to obtain results that would allow the time constant to be determined. The capacitor is initially uncharged. So let's have a look at this circuit. So we've got this switch that allows charging on this side, connecting it to the battery to charge, connecting it to the other side to allow it to discharge through this resistor. So you would need to, in your description, explain switching the switch S to position 1 to allow charging, and then you would get a stopwatch ready and you would switch to 2 and start your stopwatch, and then you would record this voltage at regular intervals as the capacitor discharged. So you could say, record the voltage every 20 seconds while the capacitor is discharging. B1. The results obtained in A2 can be used to plot a nonlinear graph from which the time constant can be obtained. Label the axes on figure 1.2 and sketch the shape of the graph that you would expect to obtain. So this is just our exponential capacitor discharge graph. So you would have voltage up the side and time along the bottom, and your graph would be a curve, something like this. Explain fully how you would use your graph to obtain a reliable value for the time constant of the circuit. So obviously we have our start point up here. And then we need to go to 0.37. Okay, so this is like V0. So we go to 0.37 of V0. And we see how long that took. And that's going to be a time constant. And then, we can take any other value. But we can look to see if 0.37 of that at another stage. Another option people sometimes forget is you can take some other arbitrary value and see how long it takes to get to 37% of that, which should also be a time constant. That'll give you a third time constant from these same set of results. So the idea then is that you take those multiple results and find a mean of them, and that's why they're mentioning a reliable value, that you didn't just do it for once. So the idea is that you find several positions where you can obtain a time constant, and then you average those.